Today we are going to start learning about the unit circle. Notice on the graph we have a circle centered at the origin and the radius is 1 unit. That's why it is called the unit circle. To better understand the unit circle, we are first going to look at some unit triangles. Notice the hypotenuse for both of these triangles are 1 unit long. Also notice that they are both special right triangles. The first one is a 45, 45, 90 degree triangle. Hopefully, if you remember the properties for a 45, 45 degree triangle, if they give you the hypotenuse as 1, you should be able to get the length of the legs. To get the length of the left leg, you need to divide the hypotenuse by 2 and then multiply by square root of 2. There it is, square root of 2 over 2. And then to get to the bottom leg, the answer should be exactly the same. Alright, let's move on to the 30, 60, 90 degree triangle. If the hypotenuse is 1, then the short leg on the bottom is just half of the hypotenuse. And then to get the longer leg, you just multiply the shorter leg by radical 3. Radical 3 over 2. Let's go ahead and review the 6 trig functions we learned in accelerated geometry. Notice I wrote the acronym SOHCAHTOA to help us review. Our first trig function is sine. Remember, sine is equal to opposite over hypotenuse. In this chapter, we are going to focus on the hypotenuse always being 1 unit. That's why we're going to focus around the unit circle. So the hypotenuse, it's always going to be 1, so we can go ahead and not write the 1 and have it just be equal to opposite side. Sometimes this will be referred to as the y value. This was not focused too much in accelerated geometry. CSE stands for cosecant. Cosecant is equal to hypotenuse over opposite. Notice it is the reciprocal of sine. It is the flipped version of sine. The next trig function we learned was cosine. Cosine is adjacent over hypotenuse. Again, hypotenuse will be 1, so we will just write cosine is equal to adjacent. This is also sometimes known as the x value. The reciprocal of the reciprocal of cosine is secant. Secant is equal to hypotenuse over adjacent. The third trig function we learned in accelerated geometry is tangent. Tangent is equal to opposite over adjacent. Sometimes we'll refer to it as the y value over the x value. Tangent has a reciprocal as well. It is called cotangent. Cotangent is equal to adjacent over opposite. If you want, you can print this slide out because it is very important and you can use it for reference. Let's see how we can use all of that on the unit circle. Let's go ahead and fill in our unit circle with the degrees from our special right triangles. Notice in the first quadrant we have 30 degrees, and then 45 degrees, and then 60 degrees. Those are the degrees in the special right triangles that we've been studying. If you look at the second quadrant, we've repeated those same degrees, but in the second quadrant to make 120 degrees, 135 degrees, and 150 degrees. If you look at the third quadrant, same thing, 210, 225, and 240. And then lastly, in the fourth quadrant, we have 300, 315, and 330. It is very important that you remember these degrees and remember where they lie and which quadrant they're in. Let's do an example. The directions say find the three trig functions for 30 degrees. Notice at the beginning we had 6 trig functions, but we're only going to focus on sine, cosine, and tangent. All right, think of where 30 degrees would be on the unit circle. It's right about there. We looked at it earlier. We're going to go ahead and draw a special right triangle using that 30 degrees. One important thing to remember is that you should always draw the triangle so that it goes towards the x-axis, always. Here, I'm going to go ahead and draw in this triangle. Notice that it is going to be a 30 degree, 60 degree, 90 degree special right triangle. We have to remember the properties for 30, 60, 90 degree triangles. Let's go ahead and label them. Remember, we're always going to deal with the hypotenuse being 1. That means the shorter side is going to be 1/2, and then the longer side is going to be radical 3 over 2. Okay, let's go ahead and find what sine of 30 is. Remember, sine is opposite over hypotenuse, also known as just the opposite because the hypotenuse is 1. If you look, the opposite side is 1/2. For cosine, it is adjacent over hypotenuse, but since the hypotenuse is 1, it is just going to be adjacent. In this case, radical 3 over 2. And then to find the tangent of 30 degrees, it is opposite over adjacent, 1/2, over radical 3 over 2. Now with tangent, we have a fraction over a fraction. Hopefully you guys remember how to rationalize that by multiplying the top with the reciprocal of the bottom. 2 over radical 3. So I just took the denominator and then multiplied its reciprocal to the top. That gives us 2 over 2 radical 3. Now, you can also reduce this. The 2's cancel out. We'll have 1 over radical 3. Now, if you remember, we're not allowed to have a radical in the denominator, so we'll have to rationalize this fraction. We did this a while back, but to make the radical in the denominator go away, you multiply the top and the bottom by the radical 3 that's in the denominator. Doing so will give you radical 3 over radical 9, but we all know what radical 9 is. It's just 3. And now we no longer have a radical in the denominator. Let's do another example. We're going to try to find the three trig functions for 45 degrees. sine 45, cosine 45, and then tangent of 45 degrees. Go ahead and try to remember where 45 degrees is on the unit circle. There it is. It's right in the middle. We're going to go ahead and draw a triangle. Remember, always to the x-axis. With radius 1. Okay. Using the rules for a 45, 45, 90 degree triangle, you should remember that the sides will be square root of 2 over 2, and the other side is also square root of 2 over 2. Let's go ahead and find sine of 45 degrees. Remember, sine is opposite over hypotenuse, or just the opposite side, which is square root of 2 over 2. Cosine is adjacent. It so happens that adjacent in this problem is also square root of 2 over 2. To find the tangent of 45 degrees, it's opposite over adjacent, so square root of 2 over 2 over square root of 2 over 2. And remember, when we have a fraction over a fraction, you take the bottom fraction and you bring it to the top and multiply the reciprocal. 2 over radical 2. If you do this correctly, you'll get 1 for tangent of 45 degrees. Alright, let's do the same thing, but this time for 120 degrees. Sine, cosine, and tangent of 120 degrees. Go ahead and try to remember where 120 degrees is on the unit circle. There it is. It's in the second quadrant. Now we're going to try to draw a special right triangle. We have to remember to draw that triangle so it's always going towards the x-axis. So from there, we're going to draw it towards the x-axis. And there's our triangle with hypotenuse 1. Now our job is to figure out what this reference angle is right here. If we have 120 degrees and 180 is here, to find that central angle, it's just 180 minus 120, which gives us 60 degrees. So again, we have a 30, 60, 90 degree triangle. Remembering the properties for 30, 60, 90, the shorter leg will be 1/2, and then the longer leg will be radical 3 over 2. Now there's something special about these numbers. Not necessarily special, but there's something different. The 1/2 is actually negative, only because it's going in the negative direction. The radical 3 over 2 is still positive because it's in the positive direction. That sometimes confuses people. Let's go ahead and find sine of 120. Remember, sine is the opposite side, which is radical 3 over 2. Cosine of 120, cosine is the adjacent, which is the 1/2, but in this case we have negative 1/2. And then tangent is opposite over adjacent. Remember, when we have a fraction over fraction, we're going to rationalize it, or not rationalize, we're going to simplify it by multiplying the top with the reciprocal of the denominator. The 2's will cancel out. We're left with negative radical 3 over 1, or just negative radical 3. A few more examples to go. Let's do the three trig functions for 225 degrees. Go ahead and try to picture where 225 degrees will be on the unit circle. Here it is. We're going to go ahead and draw our right triangle in. Again, always going towards the x-axis. Now, if you notice, this angle in the middle, we have to figure out. There's 180. To figure out that angle, you just take 225 minus 180, and it turns out it is 45 degrees. And if you notice, they're only going to be the degrees that we've been working on with special right triangles. It's either going to be 30 or 60 or 45 degrees. Just those three. Nice and convenient. All right, let's go ahead and fill in the sides of that triangle. We have radical 2 over 2, but be careful, it is going in the negative direction, so negative radical 2 over 2. And the other leg is also radical 2 over 2. And it is also negative because it's going down. All right, let's fill in our answers. Sine of 225 degrees. Sine is the opposite, which is negative radical 2 over 2. Cosine is adjacent, also radical 2 over 2, negative. And then tangent is opposite over adjacent. If we go ahead and simplify that, it just turns into 1. All right, this is our last example for the day. It does say tricky. Let's go ahead and do the three trig functions for 270 degrees. Go ahead and take a second to find where 270 degrees is on your unit circle. All right, it's right on the y-axis. Notice it's tricky because if you try to draw a triangle towards the x-axis, it doesn't quite work because you've basically just drawn a straight line. When that happens, we're going to go ahead and use some points. We're going to figure out what this point is. That point is actually 0, negative 1. All right, and I know it doesn't ask for it, but I'm going to go ahead and put the points all the way around. The point here is 1, 0. The point up here is 0, positive 1. And then the point for 180 degrees is negative 1, 0. All right, but we are going to focus on the 270 degrees. Remember, sine is the opposite side, but there's no triangle to find the opposite side. But if we remember from our chart at the beginning, sine also means the y value. And in this case, we have that as the x value, and that is the y value. And for the y value, sine of 270 is -1. Cosine was the adjacent side, but there is no adjacent. But the chart at the beginning, remember, says that cosine was also the x value. In this case, the x value is 0. To do tangent, it's still opposite over adjacent, or the y value over the x value. Now, if you remember from Algebra 1, a 0 in the denominator had a special name. Whenever you have a 0 in the denominator, we call it undefined. And that is actually the answer for tangent of 270 degrees. All right, there you have it. This is just an introduction to our unit circle. We'll be spending quite a few days working on this, so we'll do some more examples tomorrow. Thank you.